Good day, ladies and gents. We're going to be doing the Unit 1 study guide. So number 1, what is the length of A to Z? Use the following information. A is between Y and Z. YA is 24, AZ is 15X, and YZ is 189. All right, the first thing is they are talking about a line segment. So when in doubt, draw it out. We're going to draw this first. So drawing this line, we are going from A is between Y to Z. So it's from Y to Z. And then A is somewhere between there. Now, I don't know if it's over here or if it's over here. Not quite sure. So what if I guess that it was over here? And I'm going to put a little question mark right there because I am the one who's guessing. It could look like this or it could have been over here. I'm not sure. So this could be 20 and this could be 100 for all I know. I'm not sure. Or I might have guessed about right. Who knows? But we'll find out really soon. So now that we have a general idea what this looks like, because it's not smack dab in the middle, it's somewhere between, we are going to label this now. Y to A is 24. A to Z is 15X. And then the whole shebang, Y to Z, all of this is 189. All right. So now we know that this plus this equals the whole shebang. 24 plus 15X equals the whole shebang, 189. All right, now 24 plus 15x equals 189. You just solve, subtract 24. You get 15x is equal to 165. I ran out of room, so I'll put it up here. We have 15x equals 165. I'm going to divide both sides by that 15. And we're left with x equals 11. Now, you're not done. Every time you get x, you always plug it back into the picture for two reasons. One, to check yourself. Does this plus this equal the whole shebang? If it doesn't, you know you messed up somewhere. The other reason is be able to answer any of their questions. They could ask me for x. They can ask me for the left side, the right side, or the whole shebang. I need to be ready no matter what they ask. So I'm going to show you my calculator. Okay, we just got that x was 11. So how do we type this into the calculator? So this is already 24. This right here, 15 times whatever x was, which was 11. That'd be 165. And then down here, this is already 189. Now we're going to double check. This is supposed to be this plus this equals whole shebang. Let's double check. 24 plus 165 equals 189. Yes, that checks out. Now the picture, this is 165. That's small. But I'm the one who drew the picture. I wasn't sure where the A was, so that's okay. But I know this plus this equals the whole shebang. That checks out. Now I'm ready to answer their question. What did they want? They wanted A to Z. A to Z was this distance, which was 165. So A to Z is 165. That is what they wanted. Not 11, not 189 or 24. They wanted the 165. Okay, number 2. All right, so number 2, use the following information to find x. Write the value of the variable. B is between A and C. AB is this, BC is this, and AB is equal to BC. All right, the first thing says that B is somewhere between. So I draw this. So A is somewhere between A and C. B is somewhere between, so maybe it's over here. But then when I read more information, I'm like, wait. This and this are supposed to be equal, so I didn't get it right the first time. That's okay. That's totally fine. So I know this is A, this is C, and A to B is supposed to be equal to B to C, so this is smack dab in the center. So I know that this entire distance is equal to that distance, so I put these little tick marks saying that this is equal to this. Now let's label. A to B is 4x plus 7, and B to C is 20x minus 5. All right, so pause the video, make the equation, and see if you get the equation right. All right, let's see if you got the equation right. These two are equal, so 4x plus 7 is equal to 20x minus 5. Okay, pause the video again and see if you can solve for x. Go for it. Pause the video, solve for x. Let's see if you got that right. I'm going to solve for x. You might have done it differently than I did, but I'm going to do it this way. I'm going to get all the x's on one side. Then I need to move this. So I'm not moving that 7, I'm moving this 5. So add 5 and get stuff away from the x. And I get 12 equals 16x. All right, now we have to get rid of the 16. This is what trips up a lot of people. Well, I can't divide that 16. Just go through the motions. We are going to divide by 16 on both sides, right? So we're left with, I ran out of room, so I put it up here, 12 over 16 is equal to x. But keep going. What can we take out of 12 and 16? So 12 and 16, I can divide top and bottom by the number 4. And we're left with 3 over 4 is equal to x. Or 0.75, whichever one you got. The real answer is this, but we can use this. Now, I want to double check that this is right. Every time you get x, you plug it back in. So I'm going to double check. And I can use that decimal because it's a terminating decimal. Now, if it was like 1 over 3, I couldn't use it. I would have to, I'd be stuck with the fraction. So I can't use 0.3 to 3. But what we're going to do is we're going to use this fraction just so if you get 1/3, like what would you do? Okay, so how do we plug this in? How do we plug a fraction in? 4 times parentheses. We got 3 over 4 plus 7. This would be 10. And then 20 times parentheses 3 over 4 minus that 5. And we got 10 again. And that's the only places where x is. Does that check out? Yes, 10 equals 10, that checks out. Also, what would have been the whole shebang here? Well, that would have been 10 plus 10, which equals 20. Now I'm ready no matter what they ask. I have x, I have the left side, I have the right side, I have the whole shebang. What did they want? They just wanted x, so that was the answer, 3/4. Okay, number 3. Number 3, place the compass. So Amy is bisecting a line segment. So bisecting a line segment. So when you're bisecting a line segment, we are cutting it in half. We're cutting it into 2, that's sections, bisecting, 2 equal sections of a line segment. What is the missing step? All right, so for that, now we practice this, but just in case you're struggling with that, what I'm going to do is, okay, line segment, just so you can see what's going on in my head. All right, so step 1, when you're bisecting, now what really is supposed to happen is use a compass, but you can actually do this from memory. So for a compass, place the compass on the line at one end of the line segment, and what you're supposed to do is measure more than halfway, mark the top, mark the bottom. Then with that same setting, you mark the top, you mark the bottom. All right, so let's see. Place the compass at the one end of the line segment. So we're measuring from here to here. Adjust it so it's slightly longer than halfway. So right about here. Then mark the top, so it curves like that, and mark the bottom, it curves like this. And if you continue, it makes one big circle around here. Now, what's the next thing? So we set this, we marked up, so we set it here, we mark the top, we mark the bottom. Okay, with that same setting, you're supposed to go over here and mark the top, mark the bottom. So which one does that? So it's definitely not this one or this one because they said that you're readjusting the compass. So it's not C or D. Keeping the same compass width, that's the one we want. Keeping the same compass width, go to the other end and mark the top and the bottom. And then the last thing was place a ruler at the arc crosses and draw a line. So that's this. And right here, that is the midpoint. So the answer was B. All right, let's keep going. So number 4. B is between A and C. So the first thing we should do is draw the line. Here's A to C. And B is somewhere between. But I don't know, but they didn't say anything about being right dab in the middle. That's not in the middle. So it's somewhere in between. So let's say we have this. Or Or you might have gone the other direction. You would still get the same answer. So if you had B somewhere over here, you would be okay. So one or the other, it doesn't matter. Okay, now we're going to label this. So I'm just showing you two different ways how to do this. So you could do A to B is x plus 4. We have B to C is 2x minus 2, and A to C, that whole shebang, is 4x minus 1. So your picture looks like this, or it looks like this. And both are good. Those pictures are good. Okay, now, so both of these pictures are happy. Now, let's take this and we're going to solve. Now, I'm going to do a bad example first. So this one's wrong and the next one will be right, okay? I'm going to show you two different ways how to do this. All right, the first way, if you did this wrong, a lot of people accidentally set these two equal. So this is wrong. X plus 4 is equal to 2x minus 2. I haven't realized this yet, but this and this are not equal. This is wrong. But I'm going to solve this. I subtract 1x from both sides. And I get 4 is equal to x minus 2. I add 2 to both sides, and I get 6 is equal to x. Now, I haven't recognized that this is wrong yet. This looks beautiful, doesn't it? But it's wrong. This is wrong. And I'm going to show you why it's wrong. So I'm going to plug this back into here. If I plug this back into this picture, I would get 6 plus 4. I get 2 times 6 minus 2. And which that and that are equal, right? However, there's another x. You would need to plug it into all of them. 4 times 6 minus 1. That's incorrect. So when I did this, my picture, that turned into 10, that turned into 10, and the whole shebang turned into 23, which is incorrect. That is wrong. And I caught myself when I plugged it into every single position of x. So this is wrong. Okay, now let's act, oh no, I have to redo it. This was incorrect. You caught yourself. It's okay to make mistakes. Just catch yourself. So let's try this again. It was supposed to be this plus this equals the whole shebang. It was supposed to be x plus 4 plus 2x minus 2 is equal to 4x minus 1. When they're on the same side, do the same operation. What's 1x plus 2x? That's 3x. 4 plus a negative 2. Here, I'll zoom in a little more. 4 plus a negative 2, that's plus 2, equals 4x minus 1. All right, I'm going to subtract 3x from both sides. I get a positive 2 is equal to 1x minus 1. Add 1 to both sides. I get 3 is equal to x. Now let's plug it back in. Plug it back into the picture. All right, so we have the left side. If I plug this back in, 3 plus 4 is 7. 2 times 3 minus 2, I get 4, and plug it into this one. 4 times 3 minus 1, this whole shebang is 11. Does that check out? Yes, it does. That checks out. So that now I know it's correct. That's my x, that's my left, my right, the whole shebang. Now answer their question. They said, what was A to B? A to B is the left side. They wanted this. The answer was, so A to B was 7. That's what they wanted. So 7 was the answer. So the first time I did it, I was wrong, but I caught my mistake. I just restarted. That's totally fine. Okay, let's keep going. Number 5. All right, for number 5, Nico is rearranging the furniture. He wants his couch to sit along the 20-foot wall. All right, so we have this picture right here, where this is A, this is B, and this is C. So I know all of this is 20, right? Okay, now we need our little thing right here. We need our box. We know that from left, that's A to B, plus the right, which is B to C, is equal to the whole shebang AC. So the left plus the right equals the whole shebang. Now we have a ratio. They said A to B is that first number, which is 1. And then the second number, B to C, is 3. Where is that? Is that the right or the whole shebang? That's the right. Okay, awesome. So we know this plus this equals the whole shebang. What was the whole shebang? If 1 plus 3 is equal to what? 4. That's the whole shebang. And then you guys just need to make it a fraction. So put it over 4. All right, so that's our fractions, right? 1 over 4 plus 3 over 4 equals 4 over 4. Okay, so in this right here is our proportion. So this is a 1 to 3 ratio. That's what we're used to seeing. So now you take this, and what it does, it feels like this ratio flips. So the board is a 1 to 3 ratio, and mathematicians figured out that the weight so the board and the weight flip. So there are 3 A's and there is 1 C, which makes sense because we need to be closer to the heavier part, and that is exactly where B is. So we're going to have we're going to have 3 A's, 1, 2, 3, and we have 1 C. Now, where are these located though? Where is the location of these? Well, they gave us this number 20. If I put this on the number line, it actually makes more sense. The number line, if I put this like that, I know that all of this is 20. So from here to here is 20. So what would this be? Let's say, let that be 0. So we're going to go 0 plus 0 plus 0 plus 20. So let's add those together. 0 plus 0 plus 0 plus 20, that is 20. But that's not our answer. You still have to divide by how many you had. And we had 1, 2, 3, 4. So divide by 4, and our answer is 5. Which that makes sense because the halfway mark is 10, and we said we're more to the left. So 5 is our answer. And that's the answer right here, 5. So our answer was 5. Another way you could have done that was that we wanted A to B, which was 1/4. You just multiply by 20. Plus that 3/4 multiply by 20. Plus that 4 equals that 4/4 multiply by 20. So this is just another way to do this. 1/4 of 20, you multiply that, you get 5. Multiply that, you get 15, equals multiply that, you get 20, which checks out. So the board, this is 5, this is 15, the whole shebang is 20. So that was just 2 ways how to do that same thing. But we get the number 5. But this is probably the one that you're used to. Number 6. All right, number 6, they were really cool enough to go ahead and graph this for us. So we want, find the coordinate of C if AB such that the ratio of A to C, C to B is 4 to 5. All right, so we're talking from here to here. All right, so we have from here to here. And so our general thing is this is A, this is B, C is somewhere in between there. So I'm going to make a board right here. Now we know and C is somewhere in here. I just don't know where it is. So this is A to C plus C to B equals the whole shebang A to B. And we're going to take this ratio and we're going to put it over here. The first number was A to C, so that goes right there. C to B, that just happens to be this number, but they could have easily put it over here. They could have easily put that number here. So if the number was here, we would just have to find the missing. What plus this equals that? But they were nice enough to give us this. C to B was 5. So then this plus this equals the whole shebang. So what's the whole shebang? 9. You just put this all over the number 9. All right, so this is the real ratio we want, which just happens to be the same thing. So this is a 4 to 5 ratio. And we learned that these numbers switch. So that's the board, the weight is opposite. So how many A's do you have? You have 5. 1, 2, 3, 4, 5. How many B's? You have 1, 2, 3, 4. So you have, what do you have more of, A's or B's? You have more A's. So it's going to be closer to the A. And that's where C is going to be located, closer to that A. So it should be, so if this is the middle, it should be somewhere over here, closer to the A. All right, so we have 5 A's, 1, 2, 3, 4, 5. And we have 4 B's, 1, 2, 3, 4. All right, now what was the coordinate? Your coordinate for A is -4, -6. And I write that 5 times. and your B was positive 5, positive 6. And I write that 4 times. And now you're just going to add those together. So I like to bunch them together for myself. So there are 5 A's plus those 4 B's, which are 5. So this plus this would equal 0. Negative 4, and I did 5 times, and I'm sorry. Okay, and then negative 6, there are 5 negative 6's, plus there are 4 6's. We got negative 6. Excellent. All right, so we add those together now, but is that the answer? No, because 0, so this is my x, that's my y. Negative 6, that's not even on the line, is it? What did I forget to do? I forgot to divide by how many coordinates I had. How many coordinates we had? We had 9. So divide each one by 9. So divide by 9, we get 0, comma, and then I could divide top and bottom by 3, and I get negative 2 over 3. And that's another common mistake. A lot of people drop that negative. If I try to plot that, that's so 0, negative 2 over 3, that's 0. 2 divided by 3, that's negative 0.6 repeating. All right, if you accidentally thought it was a positive, 0, comma, and this is x, my y, 0.6, that's not on the line. Oh, it's supposed to be negative. Yeah, okay, now it's correct. So which one is the answer? D. All right, and that's number 6. And we're going to flip over to the back side. Okay, number 7. Number 7, Nate wants to visit his friend Mac before going to the park. Nate's house is located at negative 4,4, while the park is located at 8,6. So we should definitely have graph paper. So have graph paper, graph this, and it'll be more accurate. So when you have graph paper, it would be looking, so negative 4, positive 4. There is that's Nate. And then positive 8, positive 6. Looks right here, so that is the park. So it looks something like that. Okay, and find Mac's house, which is halfway between the Nate and the park. So it has to be somewhere halfway, and that's another word for that is midpoint. So we're going to do the midpoint of this. And what midpoint is, you stack them one on top of the other. There's one of those, there's one of those. You just add them together. Just like what we were doing before, add them together. So negative 4 plus 8, we got positive 4. And 4 plus 6, we get 10. But we're not done. Positive 4 and a positive 10 is way up here, so that's not right. What did I forget to do? I forgot to divide by how many we had. And there were 2 of them. So divide by 2. And that was 2, 5. So 2, 5, yes. And it's on the line, and it is smack dab in the middle. So our answer is 2, 5. Excellent. Keep going. Number 8. On a number line, m is at negative 7 and n is at 4. So on a number line, here's 0, 1, 2, 3, 4, 5, 6, negative 7, and 1, 2, 3, 4. All right, so we're here and we're here. Okay. We want the midpoint. So we have negative 7, and we're going to add, that's our first point, and we have 4. So what are we going to do? We're going to just add those together and divide by how many we had. Negative 7 plus 4 is negative 3. Then you divide by 2, because there's 2 of them, right? And that's our answer, negative 1.5, which that checks out, negative 1.5, and that looks correct. Now, there's a very big common mistake on this one. Negative 7 plus 4 divided by 2, this is incorrect. This only divided the 4. What you're supposed to do is negative 7 plus 4 equals, then divide by 2. That's what you're supposed to do. So what you're supposed to do is negative 7 plus 4 equals, then divide by 2. So be very careful with that answer. And here's the answer. And notice they gave us the positive version of this as well, but the positive version doesn't even make sense. That'd be right here. That's not halfway in between. So that doesn't work. So when in doubt, draw it out. All right, number 9. All right, so for number 9, they said that R is the midpoint of this. That means that the left side is equal to the right side. So 7x minus 5 is equal to 4x plus 1, but that's in parentheses. All right, what I want you to do is pause the video and solve for x. All right, you should have solved for x. Now, there's a very common mistake here. 7x minus 5 equals, you have to distribute. That would be 4x, and that would be plus 4. That's the big common mistake. A lot of people forget to distribute. We're going to subtract 4x from both sides. We get 3x minus 5 is equal to a positive 4. Add 5. You get 3x equals 9. Ran out of room. 3x equals 9. Divide both sides by 3. X equals 3. Now, if you forgot to distribute, you got the answer was 2. But if you plug this back in, so a lot of people accidentally forgot to distribute, got the answer was 2. So if you got the answer was 2, which is wrong, you would have got that this side was 9 and 4 times parentheses 2 plus 1. You would have got this was 12. Does 9 equal 12? No, it doesn't. So if you plugged your x into this correctly, if you thought x was 2, you would have caught yourself. So let's try this again. 7 times 3 minus 5 and 4 times parentheses 3 plus 1 is 16. They both work. So this is 16, this is 16. That checks out. There's no other x's. And just because I'm curious, what would have been the whole shebang? That'd be 16 plus 16, which is 32. So these tricky buggers, they gave us x, they gave us the left side, the right side, and the whole shebang, right? That's what we found. And look, here's x, here's the left side and the right side, and here's the whole shebang. Oh man, they're trying to trick us. They have all those possibilities. What did they want? They wanted R to S. And R to S was what answer? 16. That's the one they wanted. So they were just trying to trick us. So be very careful. Right, number 10. Number 10, find the coordinates of P that represent that the weighted average of A and B, where A is 2 and B has a weight of 3. 1, 2, 3. So what do you have more of, A's or B's? Yeah, B's they're more of that. So this is the halfway point. So we want to be closer to the B. So it has to be somewhere over on this side, closer to the B. So we have 2 A's, we have 3 B's. Where was A? -3, and I wrote that twice. And B was 2, 2, and 2. All right. So now what we're going to do is we're going to add those together. -3 plus -3 plus 2, 2, and 2. And the answer was 0. But you're actually not done. You still need to divide by how many you had, which was 5. And 0 divided by 5 just happens to be 0. So you would have lucked out on that one. Be careful, because sometimes if you had done the backwards version of 2 plus 2, and then -3, -3, and -3, divide that by 5. Look at that. If we had accidentally got these backwards, that answer was on there as well, -1. So be careful. So not only do they give us this version, but they give us, if you got these backwards, you would have had that on there too, and that would have been incorrect. So be very careful. Make sure you're dividing by the total as well. Okay, number 11. All right, so on number 11, the first thing you want to do is graph this. So graph this actually on graph paper to double check yourself. All right, so -4, +2, and +3, -6. So it looks something like that. Hopefully you're doing it on real graph paper. I'm just being silly and didn't bring it with me. All right, so it looks something like that, right? On your personal graph paper. And then so it looks, I'm going to make a general graph, right, or general idea of what it looks like here. Then they said the weighted average of points A and B, where A is 2, 1, 2, and point B is 5, 1, 2, 3, 4, 5. So what are you closer to, A or B? you should always be closer to the heavier part, which is B in this case. So we're going to be closer to the B. So we have 2 A's and we have 5 B's. 1, 2, 3, 4, 5. Your A was -4.2, and I write that twice. Your B was 3. 1, 2, 3, 4, 5. -6. 1, 2, 3, 4, 5. All right, so what we're going to do is we're going to add those together. When I add those together, I get this side would be 7, and then this column would be -26. But you're not done, because if I try to graph that, +7, -26, that'd be way down here. So that's not even on the line, is it? It's on the line segment. What did I forget to do? Oh, I forgot to divide by, there's 7 of them. Divide by 7. And you get that this is 1, and this we're stuck with that fraction, -26 over 7, which is right here. Now, I want to double check that that works. So that's 1 and -26 divided by 7. That's about -3.7. So let's see. 1, comma, -3.7. Yes, that does check out. And look, it's closer to the B. So that does check out. Everything looks right. So that is the correct answer. Number 12. All right, so number 12, the first thing you want to do is graph it. So do it actually on graph paper. I'm just doing a general idea. So +7, +3, and -3, -10. So this is my A, this is my B. All right, so the general idea, so this is what you really draw. So on your paper, this is B, this is A. They said that, so the number, the R on the 4 cut off, sorry about that. So A weighs 4 times as much as B. So 1, 2, 3, 4, and B would have to be 1. So what are you going to be close to, A or B? In this case, it's going to be A because that's the heavier part. So we have 4 A's and 1 B. And where were those located? So 7, 4 times 3. So 7, 3 is your A, and -3, -10. We're going to add those together. So 7 plus 7 plus 7 plus 7 plus -3. We pop out with 25. 3, 3, 3, 3 plus that -10. We pop out with the number 2. But if you graph that, we're still not done. Where is that? That's +25, +2. Oh, that's not even on the line, is it? What did I forget to do again? Divide by how many you have, which is 5. Divide this by 5, this by 5, and we get 5, and we get that fraction 2 over 5, which is right here. And I ran out of room, so I put it up here. That's 5, 0.4. So let's check that that works. So, +5, +0.4, that's right about here. And yes, that's closer to A. That does check out. Boom. And the very last one. Woohoo! Last one, guys. A handyman company serves the customers from 2 cities that are 50 miles apart, and that's Jonesville and Bellevue. All right, so Jonesville and Bellevue, and they're 50 miles apart. Okay, so then the company would like to position a new office between the 2 cities using the weighted averages based on their typical number of calls received in each city. If Jones weighs 3, 1, 2, 3, and Bellevue weighs 5, 1, 2, 3, 4, 5. So what are you closer to, J or B? You're going to be closer to the B because it weighs more. So we have 3 J's and we have 5 B's. And we're supposed to add those together, divide by how many we have. But where are they? Well, we know that this is 50 across, right? So if we put this on the number line, this would be 50, but what would this number be? Let's just make it 0. 0 to 50, and that's a 50 apart. So J is 0, 0, 0, and B is 50, 50, 50, 50, 50. All right, so we're going to add those together. And we get 250, which is not on the number line. What I forget to do, divide by how many you have. And we have, that is 5 and 3, which is 8. Divide by that, and you get 31.25. So that should be our answer. Now let's double check. So going right here, we know what the halfway mark is 25, right? Does 31.25 work? Yes, that does check out. So we know from here to here is 31.25. We know the whole shebang is 50. Can you tell me what the office to Bellevue would have been? How would you find it? Well, you know that this is 50 and that's 31. You would just, this plus this equals that. Just subtract that 31.25 is 50 minus 31.25, and this distance would have been 18.75. So we were ready no matter what they asked. If they said J to the office is this much, B to the office is this much, the whole shebang is 50, but they wanted this one, and we're done. Hopefully that helped you guys out, and have a great and wonderful day.